Subtract the sum. This kata can be more difficult than regular 8 kayu katas, let's say a 7 or a 6. Good to know. Complete the function which gets an input number n such that n is greater than or equal to 10 and n is less than 10,000. Then sum all the digits of n, subtract the sum from n, and it is your new n. If the new n is in the list below, return the associated fruit, otherwise return back to task 1. So here we have the number 325. We add up those numbers. 3 plus 2 is 5, plus 5 is 10. Then we subtract 10 from 325. That gives us 315. It tells us that's not in the list. So we're going to repeat the process here. 3 plus 1 plus 5 gives us 9. 315 minus 9 is 306. 306 is not in the list. And then we do 3 plus 0 plus 6 is 9. 306 minus 9 is 297, which is not in the list. So we keep going until we find the first n in the list below. There is no preloaded code to help you. This is not about coding skills. Think before you code. Okay. And we have the numbers 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. Yeah, 21 through 30 through 40, 50, 60, 70. Wow, there's a lot of fruit out in the world. 80, 90,
I think
up to 100. Okay. Oh, they repeat. Yep. Pineapple. Good. There's not that much fruit that I'm missing out on. I was like, whoa, I ate like 3 fruits and they got a lot of fruit here, but you're right. It's a lot of repetition. Okay, good. Cool problem. Let's get started. So the first thing we ask ourselves here is, what is our base case? And another way to say that is, what is the simplest, sometimes we might think of that as smallest, valid input? So who has an answer for that or an idea about what our base case is here? I'm watching the chat too, to the best of my ability. Herman, go ahead.
If you get an input of 10.
10. Vandana is also in the chat saying the same thing. Thank you. 10 is the smallest valid input. And if we get 10, then what are we meant to return? One.
Yeah.
Sum all the digits of n, 1 plus 0. Subtract the sum from n, 10 minus 1. That gives us 9. If the new n is in the list below, she says apple, apple. Looks like apple. Yeah? Okay. So let's work on that. So let's go write our first test. Oops, not there. Go down to our testing block here. Okay. Zoom, you are not helping me out. Here we go. All right. Oh, they've already got it for us. Here's 10. Here's Apple. I didn't see that, but great. They've already put our base case in for us. Very cool. So we can go ahead and run our code, clicking on test. And we see expected undefined to equal apple. All right, let's write some code. So one thing we could do is we could just say return apple. After all, that will work for at least this test like that. And then we could go on from there. Or we can go ahead and solve for 10 now. Let's throw in 11 here as well. And 11 would be 1 plus 1 is 2. 11 minus 2. Oh, it's also apple, actually. Interestingly enough, let's move on to 12. So we start to see some kind of pattern here. 1 plus 2 is 3. 12 minus 3, 9. I guess they're all going to be apple. Right? 1 plus 3 is 4, 9. All right, let's skip to something else. Those are all going to be apple. All the way up until 20. 20. 2 plus 0 is 2. 20 minus 2 is 18. What does 18 give us? 18 gives us apple. Nice. And then that means everything's going to be apple. Seems like. Because then if I go I don't know if
Can you
this,
try 22 or 23, something like that?
sure,
Yeah.
so 22, right? It's the same thing, because it's 2 plus 2 is 4. 22 minus 4 is 18. 18 is apple.
Apple, right? So 23 would be 5. Oh, that's going to be 18 again. Yeah.
That's gonna be apple, yep. So
Yep.
let's move on to 30. See what 30 gives us. 3 plus 0 is 3, which gives us 27, and 27 is apple. I think they're playing a joke on us, right?
Right.
Now
Yeah.
all the 30s are gonna be apple. All right, so then if we go up to 40, say, okay, 40,
That's going to be Apple.
it's gonna be apple, because it
Yeah.
goes right back to 36, right?
Yeah.
Okay, so
Try
it seems like,
if you
go
took
ahead.
48. Nope, that's going to be 3. 48 is going to be 4 times 4 plus 8 is 12. Oh no, then that would take you to 36.
There, that'll take you to grape. That would
Yeah.
take you to 36.
4
48,
plus-
oh yeah. 48 is 12, yeah, it's gonna take you back to 36 apple.
Yeah, it's a wicked joke because no matter what you do, it goes back to Apple.
Okay, so she says 25. 25 minus 7, right?
Yeah,
2
but
plus 5
that's
is
gonna be
7.
18. It's gonna bring you
That
back to
goes back to 18,
Yeah.
back to apple. Right, Vandana? Still apple.
still Apple. So you have to find something. 24 is 6, and that's minus from that. That's gonna go back to 18.
Okay, how about 100? 1 plus 0 plus 0 is 1. 100 minus 1 is apple.
Right.
99. 9 plus 9 is 18. 99 minus 18 would be 89, 79, 77.
81.
Go back
80.
to 70s.
81.
81. Yeah, thank you.
Apple.
81. Apple. Cool. So I couldn't say for certain, but without going through every single one, it seems like any number under 100 gives us apple. Now, I just want to point out, I think this is actually a very good way of using test-driven development, right? Because we could have tried to write all this logic and make up a big object and put all of the numbers in there. But instead, I'm thinking that actually all we need to do is say return n is less than 101 apple. Else, what are we supposed to return if it doesn't? We're supposed to do this process, I realize. Otherwise, return back to task 1. Okay, so otherwise, we're going to call this again with our new n. So all that's left to do here is do the process. That's the technical way of saying sum all digits of n, set n to n minus sum of digits. And then we do this here. This will be recursive in that we're going to go right back to the top here. But before we do any of this, let's see if this part is working, because all of our tests so far are less than 101. So we should just get apple for all of them. So let's run our test. Oh, that didn't work. If n is, I'm sorry, less than, not greater than. That's my bad there. Good. So we see that all of those tests are passing. Let's open up our tests again. And let me be a little more descriptive here. Let's say, describe it subtracts the sum of digits, then checks if less than 101. If not, repeat. That's something like what we're doing here. And then here we want to describe these cases. It handles numbers 100 or less. And with that, let's go ahead and add a couple more numbers here. Whoa. Like 100, 99, and 80. And I'm just choosing a few numbers at the high end. I'm not going to put every single number here from 1 to 100. Now 80, let's check it. We didn't check it specifically since we're writing a test for it. Let's check that one specifically. So 80 is 8 plus 0 is 8. 80 minus 8 is 72, and 72, shocker, is apple. Okay, cool. Run our test one more time. We just wrote some new ones. We see all green, very good. Now we will write our next it block. We will try to at least. This is a bit of a, come on. I can't see properly here. There we go. I'll do it right here. So we say it handles numbers between 101 and 10,000. And we'll do test dot assert equals.
You wrote text.
Correct,
That's
son. Oh, thanks so much. I'll go back and fix that in just a second. Test. Okay. 101 is equal to 101 minus 2 is equal to 99 is equal to apple. Do you think everything is just apple? That if we just return apple for everything, we've won? I think maybe that's the case. So anyways, let's give it a try. Test it. And okay, it hit this condition here, right? It says, hey, you didn't subtract the sum. You called this again. It's just going to go over and over and over because n is not really getting any smaller. So for the sake of our own edification, let's go ahead and do this process. Although I'm more and more convinced that we just need to return apple for every single number, and that's all there is to it. But let's figure this out. So how do we get the digits of n? We can do, let's write a new function here. Let's say function sum digits. Yeah, that's fine. And then we'll put a number here. So first get all digits. Then add them up. Get all digits. To get all the digits, we can do something like, let's do let digits equals num dot to string dot split on every character. And then to sum them up, we'll do return digits dot map. We'll reduce these actually. Digits dot reduce. Here we have our sum. Here we have a digit. And we want to say sum plus equals number digit. So we're taking the, let me explain this a bit. I am just on too small of a screen today. There we go. All right. So here we are given a number. Let's say it's 101. Then we convert that number to a string. I'll try and follow this step by step. That looks like 101. That's this part right here. Then we split it on every character. That will create an array that looks like 1, 0, 1. Okay. Then we go ahead and reduce them. So what reduce does is it says, okay, take this second part as our starting value and set that to sum. So it will say sum equals 0. And then add to the sum the first digit. Now the first digit gets converted to a number. So it's 0 plus 1, which obviously equals 1. And then the new sum is 1 plus the next digit is 0. 1 plus 0 is 1. Then we do it one more time and it will be 1 plus 1 equals 2. So this block of code here will return 2. And then this whole function will return 2 for 101. Should we do all of this within a while n is less than? No, because the way we have this function set up, every number comes in. It says, hey, is this number less than 101? If so, return apple. Otherwise, go back to the top of the function and do it again. So as long as we do this process of sum all digits of n and then set n to n minus sum of digits, n will always be getting smaller as we go. Again, I really don't think we need to do this. I think this is problems like just kind of playing a joke on us, but I do think it's, in many problems, this is necessary to find the sum of the digits. So I think it's a nice thing to see. So with that, now here we can say const sum of digits equals sum digits passing in n. And then here we can say n equals n minus sum of digits. And now I think we're done. We've got a mess here to clean up, but looks good. Let's go ahead and run that for 101 now. I mean, for all of our tests, but also 101. Yeah, we see that looks fine. Now, anything we run is just going to return Apple. So I'm going to throw a few more numbers in here. I shouldn't say that. I don't know that for sure, but I feel pretty confident that every number is going to come down. So we say 263 and 1045 and 10,000. Let's test it. Yep. I think we're good. Let's go and clean up. And by clean up, what I mean is I'm going to delete all of these notes that I made for myself as I was figuring out this problem. I'm going to delete this one. Looks good. If you would like to leave this kind of pseudocode, I think it's okay, but like this has no reason to stay. This definitely needs to go. That needs to go. This should go. Leave our code nice and clean, easy to read. It's good practice for any professional experience later. Yeah, there we go. So we've got the function that they told us to write, subtract sum. We've got sum digits, a little helper function to help us get it done. And we go down, we return Apple. I run my tests again to make sure that I didn't break anything while cleaning up or forget anything. And with that, I'm ready to attempt. Does anybody have any questions here? Okay, I really think that's it. Let's see if that works. See if I'm missing it. Yeah, that works. All right, now let's just show how we don't even need to do any of that work. It was just a joke on us, right? So comment out some digits, get rid of this, get rid of this, comment out this, run the function, return Apple, no matter what the number is. And now we go down here and click on attempt, and we pass. Let's clean that up one more time. Now we'll just get rid of everything. Go ahead.
Yeah, what if excuse me, what if it's only because of the way that they organize the numbers corresponding with the with the values for the fruits. That's why I returned the apple. So that's my opinion or suggestion. I think if they put more effort into it to try to make it actually work out from what the problem was describing, then it probably would have worked differently. Like we probably would have needed the type of code that you worked out.
Yeah, so with like here's one reason I wanted to create CodeTrack, right, is because on CodeWars there are so many thousands of problems, and some of them I just don't find that useful for growing as a developer. So so like this problem is not on CodeTrack. You will not find this on any of the lists on CodeTrack, because I wouldn't put this problem on CodeTrack. It's a cool problem. It's fun. It's kind of a joke, whatever. It's a nice way to see, like, many times something that looks to our brain complicated is actually very simple, and we shouldn't let our brains trick us if we can possibly avoid it. So I don't think it's a useless problem, but it's not one that I choose to put on CodeTrack. And that's for that reason exactly. Hey, I don't love this problem. I don't think that you're like growing as much from this problem in most cases, maybe not in all cases. Therefore, I'm not going to put on CodeTrack, but it's here.
Yeah,
do it, don't do it. It's all good.
No, I think that was a reasonable and a valid point that you made there. I was just kind of suggesting that probably it could have been of more value if they took more interest in where they place the values of the fruits corresponding with the numbers.
Yeah. So like, okay, this is essentially what we did, right? I just didn't write it as an arrow function, but fine, looks good. Basically. Here's someone that didn't get it, right? This is what it looks like to not get this problem, to write out all of this.
Right.
And then they did what we did here. And again, I do think this is just a huge lesson in test-driven development. If you'll just start with your simplest case, you see how I started with the simplest case, you're like, why, Jordan? It's so obvious. 10 is obviously apple or whatever. But then I go to 11 and then I go to 12. Why are you doing this? It just seems like this is like for babies. No, but by starting like what for babies, we find the pattern quickly and then we see, oh, you know what? There's actually nothing to do here, which is great. That it is in that way, it's probably a great lesson on test-driven development.
Yeah, that's a valid
Um,
point. I could take that. Yeah, I can see that.
So this again is pretty much exactly what we did, right? Find the sum, check if it's greater than 100. If so, go back to the top of the function. Otherwise, return this. Return apple. If n is a joke, return bullshit. Otherwise, return apple. Obviously, they're saying this person's just being funny, doing all this crazy stuff, whatever. Again, somebody who didn't quite get the joke here. I don't hope that's none of you guys. We're gonna come across someone and be like, anyways, same. Anyways, these are all just like find solutions, but they don't see the pattern. Anyways, cool, great. Well,